Right. Can AI replace programmers? Betteridge's law applies. The headline to the question mark could be answered by the word no, but this is a talk. So the answer to cut to the end is going to be yes, but. So I'm going to take a bit of a walkthrough, think about what we mean by code and programmers being replaced by AI. I'll give a short whirlwind example of one technique that you could use, and we'll see what happens. And then we'll sit back and have a think about this. So the theory is that if you're an adept programmer, you should certainly be able to code up FizzBuzz. Some of you might have come along across this code kata before. So if a programmer needs to code up FizzBuzz, we need AI to code up FizzBuzz. So that's what we'll find out today. Can AI code FizzBuzz? If you've not come across FizzBuzz before, there are those who say it's a drinking game. And there are those who say it's a little code kata or practice exercise. So you count through some numbers, usually starting at 1, conventionally going up to 100, that's not obligatory. And you count 1, 2, but every multiple of 3, you say fizz. So we go 1, 2, fizz. Every multiple of 5, you say buzz. 1, 2, fizz, 4, buzz, 6, and so on. And this means multiples of 15 are substituted with fizz, buzz. So you're going to end up with some numbers and some words spewed out. Now, this is where we start to learn a little bit about AI. So if you've not tried any AI or machine learning programming, you can learn about some AI on the way as well. Almost all approaches to AI have got the idea of a fitness function or a cost function. You see how good or how bad something is. And that's usually in the form of a test, a function we call, and we see whether it passes or fails. Or possibly it gives us a score back. Now, writing good tests is really hard. It's really important, but it can be really difficult. How are we going to test FizzBuzz? I could write down the list of all the outputs I expect. I could write some code to do that. But if we're trying to get AI to replace programmers, and we do this by me writing the FizzBuzz code myself, then that means we can't be replaced, which some people might think is a good idea. If anyone's tried the FizzBuzz kata before, it is really difficult to come out with a full set of tests that catch all the cases without just writing out the list of all the outputs you expect for each input. So, as I said, that means if we implement FizzBuzz in order to get the machine to learn to code FizzBuzz, we failed to replace ourselves. The one thing we've learned so far is testing is really important. We'll see how we use the tests when we get to try and make some AI write some code for us. What I'm going to do is cheat. FizzBuzz has a long vendor, as I, who you may or may not have come across, called Kevlin Henny, who's talked about it several times, and many other things too. And he's distilled down 8 principles or properties that need to hold true for your solution to FizzBuzz to cover all the bases, do all the things that are required. So I'm going to use these 8 principles when we try and make AI generate code for us. We're basically checking that we either get FizzBuzz, or a number, decimal string, as it were. That we've got the fizzes in the right place, the buzzes in the right place, and we haven't got any fizzes or buzzes or FizzBuzzes in the wrong place. And finally, if we've got a number, that's the second principle, this corresponds to its ordinal position. So 1 is first, 2 is second. And with a bit of thought, you might be able to convince yourself that that's all the basis comes. It's got 8 properties that we want to hold true. So hold those in mind. We'll see them in code later on. So I've cheated and nicked the test from the internet in previous talks. I skipped ahead there. So if we're going to be replaced wholesale as programmers, that means the people who want the code, like the customers, are going to have to think long and hard to come out with tests. Okay, I'm going to use a variation on genetic algorithms to generate the code. So I'll give you a quick walkthrough of how genetic algorithms work. They're basically searching for what you might call a tuple, or list of numbers or strings or flags that solve a problem. The way they work is you generate some random lists, tuples, maybe pairs or maybe numbers. Again, it could be strings, it might not be pairs, it might be triples or quadruples and so on. Start with something random, and then with your random set of things, choose 2 better ones, and that's where the tests come in. You can test your setup against what you want and give them a score. Don't always pick the best ones, just pick some better ones, and then take maybe a number from one and a number from the other, cross them over, and then you've got a new pair. So we've done something random to set things up, we've tested things, we've chosen things to make some new things. And the idea is that's guiding us towards better places whilst exploring around. To make sure we do enough explore, we might mutate some of the values, make them a bit bigger or a bit smaller. Or if it's a Boolean flag, flip from true to false. So what we're doing here is, instead of brute forcing and trying every possible pair or triple of numbers, we're trying quite a lot of them, but we're trying to guide ourselves towards the best solution. If you could enumerate every possible thing called brute forcing, you might as well. But there's some circumstances where that might take hours and hours and hours. So it's kind of like trying stuff out, see what happens, but guiding by the test, nudging towards better things. And we pull this all together. So starting with something random, try them all out, and then replace either all of them or some of them using our tests. And eventually we'll end up with some pairs or triples or quadruples that solve the problem or nearly solve the problem. And you can apply it to all kinds of things. Got some examples in my book, and I can chat afterwards if you want some real world examples. As I said, some more in my book. Now, I talked about having tuples, so pairs of things, triples and so on. But we could do something really similar with a tree structure. I'm not sure, were I in the room, I could look around and see what anyone had come across before. Have you ever thought of a program as a tree structure? Most programs have got this fundamental idea of an abstract syntax tree, which is an expression you can build up. The example I've got on the screen, you've got a Y on the bottom left in green and a 3. And they join up to a star, which conventionally means multiplied. So that part of the expression would be Y times 3. And as we got the tree, we then add an X. And on the right-hand side, we've got an X plus an X, and we're finding the maximum of them. So you can use trees to express programmatic concepts. There's loads more details on how different ways to set the expression of trees in a book that's really old, and you'll be able to find it online free as a PDF. And this book's about a programming language called Lisp, which was designed so that it could modify itself. That's not quite the same as generating a program from scratch with AI, but some of the older programming languages were designed around the idea of AI. And a lot of computing concepts are have sprung out of AI. In fact, if you think about programming and look how programming worked to begin with, it would have been tweaking files and knobs and setting noughts and ones yourself on straight in the hardware. It took a long while to come across the idea of what were then called higher level languages like Fortran or C or COBOL or ALGOL. If you think about what happens when you write a program, you type something in and then the computer runs a program on it that turns it into a program. So that was referred to as automatic programming years and years ago. So I'll put it to you that as a programmer, you're partly replaced by a computer anyway. You aren't programming. You're typing in some high-level constructs, and then an interpreter or a compiler turns it into something the machine understands for you. Also, quite a long time ago, right back to the beginning of computer science, a guy called Alonzo Church, who you may or may not have heard of, suggested the idea of computers automatically generating their own circuits. So that would involve the computers building the computers, as well as being able to program themselves, which might conjure up images of certain sci-fi movies. That was referred to as the idea of program synthesis. And I've noticed just in the last few months, several large organizations such as Microsoft started to talk about program synthesis. This is becoming on the horizon thing again. I think if you watch over the next few months, it'd be really interesting to see which companies do start generating code from scratch. And then there's one specific way of doing this called genetic programming, which is why I told you what genetic algorithms are about. And that's what we've just said. If we start, instead of with a pair of numbers or a triple, start with a tree, we can do something similar to what we did with the for loop, the crossover, and the mutation just now. So we've already said computers are doing loads for us. Let's get this happening. Let's see if we can replace ourselves, or at least if we can make the computer do FizzBuzz. I'm going to run through high-level details of an example in Python. There are other frameworks available, and in theory, you could do this from scratch yourself. So we've got our familiar tree again, and some frameworks work directly on the abstract syntax tree. This one doesn't. You tell it which functions you want it to use. So those are the nodes higher up in the tree. And then you tell it what specific things it can put at the leaf node. So there might be specific numbers, or get it to find a number, or specific strings, and so on. So you tell it how to build up its random trees. As I said, you add all these, you add the primitives, and you add the terminal, so it knows how to make one tree. And then it's going to make several of these. We want it to maximize the fitness. We're going to use the 8 principles from Kevin Henry's tests. You could minimize things as well, so there are always options. We're going to make it make a tree. We're going to do some setup. Like I said, it's going to get a score out of 8. So we're going to, if we code up our tests, and those correspond to the 8 we talked through earlier, you need to watch out, because of course, if you randomly slam together an expression tree, you might have something that blows up horribly, doesn't work, divides by 0, So you might want to have a safe run around the top of it. And that returns -1 if the program doesn't work at all, or throws an exception, or does something horrible, basically. But this will give us a score somewhere between -1 for terrible, all the way up to 8 for job done. The deep framework has the idea of a toolbox that we add all these bits into as we go. We've got some decisions to make. I'm going to run a tournament. So when I said a tournament with size 3, what I'm saying is I'll randomly pick 3 of my programs, or these trees, try them out, and the one with the highest score in the tests can breed. and make a new tree for me. So set everything up, decide I've got 75% chance of breeding something new, 50% chance of changing one of the numbers in the trees or the expressions, or that. So here mutation would mean swapping one thing from the operator set for another thing. I'm going to have 75 generations. So remember the genetic algorithms, we did something for a while. So here we'll do this 75 times. And I've told it to try 4,000 programs in each step in the for loop. And it'll drop out a Hall of Fame for us, which tells us the best one that's happened so far, along with a log of what happened and the final population or set of trees. And it works. Now, I've just told you several magic numbers I came up with. It takes a lot of experimentation when you're doing machine learning to find the right parameters to use. You often got how long do you run for? Like I said, how many times around the loop? What's the probability of something happening? Because loads of these are probabilistic. You don't always do the same thing. Then you'll get a predictable program. And it wouldn't look like it was being intelligent because it would be doing the same thing deterministically each time. Great. So we put a lot of thought into the test. We had to make up some random numbers or to choose how to drive things, how many, how long for, how often, what's the probability. And starting with the tests, we've generated some code. Don't know what your Python's like. Don't know if you want to see the code. Just pause here for a moment. At no point in the test did I tell it to write nice code, readable code, or avoid redundant things. Don't know if you notice in there, it's doing things like checking either you've got buzz or you've got buzz, then do something. Well, no matter how new you are to code, if I say either buzz or buzz, I could just say if buzz. So this could be a little smaller and neater. It's not brilliant, but if AI replaces programmers, no one will ever look at the code, right? So perhaps that's okay. Now we don't have to look in the code anymore. Let's just step back and have a little think about what we've learned. Careful what you wish for. If somebody wants to replace all us programmers, they're going to have to get really good at writing these fitness functions or test functions. We also need somebody to choose what sort of parameters to pick for each of your AI and machine learning models. You could theoretically do that with more AI and machine learning, but that would need to be tuned as well. And then it's turtles all the way down. That's a hard problem. Keep your eyes out for program synthesis. It's a very old term, like I said, but I can see that coming up on the horizon at the moment. I could share a couple of things that are going on out there at the moment. So automate what you can. I've said at the beginning that if you use a compiler or an interpreter, you've already got some quite intelligent stuff going on in there for you. If you use a language that's compiled and you've got an optimizer going, that might well have some genetic algorithms baked inside it so as it can try and fine tune things for you as they go. Would you see that as AI? Well, that's my question to you, I guess. Do you think this is AI? You can generate code that fulfills requirements without any programs involved. Is AI going to replace us? Well, I'll leave you to decide. And I'm open to any questions now. I can share the code for anyone who wants to play with it and dig it out. It's not fun. But there we go. Computers can replace programmers. I suspect they probably won't, but keep your eyes open on program synthesis. And that's me done. I can see one question. What's my favorite language? See, I actually really love C++. it's really easy to knock together something quite quickly in Python. So I'm torn. It depends what day of the week it is. Yeah, I actually quite like some of the functional things like Lisp. I think it's good to learn a new language once in a while, because then it gives you different ways of thinking about the world. I hope that's answered the question. Mostly C++, definitely Pythons can be really nice. Any more questions? I'm going to put the horrific code back on the screen. Look at that. Which programming language is best for AI? Well, see, it depends what we mean by AI. As at the moment, I think most frameworks have been written in Python or have got a Python hook for them. So that's become like the lingua franca. A lot of people are doing that. But if you open your eyes and look more broadly, there are frameworks out there in Java. If you want some grunt power, then you could drop down to some C or C++ or Fortran. I don't think there's a best language. And I mentioned Lisp for a reason earlier on. That was designed so as it could be self-altering. So I think most people would tell you, if you want to get into AI, learn Python. If you want to play with Keras and some deep learning stuff, yeah, that's the way to go. Is it the best language? It's the one everyone's using at the moment. That might not make it the best one, if that's answered the question. What do you think about Facebook's AI related? They've been up to loads of interesting stuff. I think you could argue they've driven some of the cat dog thing that's automatically labeling photos and things. I've not seen all of their latest experiments, and I've now got a muddle in my head, and I'm desperately trying to remember which large tech company has been playing with what. And actually, did you have a specific AI Facebook specific thing in mind that you were asking about? Or were you asking more generally about what I think about them experimenting on us, really, and our data? There's so many ways to take that question. I think there's a broader conversation to be had about who holds what data, what they do with it. There's a lot of talk around ethics in AI at the moment. So yeah, that could happen in one of two ways. There's certainly like pushing the envelope, coming up with loads of new interesting tech for us. What data they've got on us, that's a question. But that's a question for all the big tech companies. Okay, so I see a response back about when two systems communicating with each other. So is that the one that developed their own language? I think chatbot technology is really interesting, and I see lots of innovations there. If you've ever come across something called EchoBorg, I think that's far more interesting. There's a lot of stuff going on there. Yeah, natural language processing is another big area where interesting stuff is occurring. What's actually happening when two machines talk to each other? Who knows? I think I start going that's a realm to explore further and see what happens. And my mind's now set off with a variety of different sci-fi stories. But I think sometimes sci-fi drives how the AI thinking works and how science works. Fascinating. I can't give you the specific details. I can't predict the future, but yeah, watching with interest, definitely. Thank you very much for taking time out to listen to me. As I said, there's the link to my book. If you want to just download code and play with it, help yourself. It doesn't include the genetic programming. It goes through more details on genetic algorithms and several other machine learning techniques. But keep your eyes on this stuff. It's really interesting. Keep your eyes open for program synthesis and see where that goes. And that's me done.